This proof here involves just looking at whether or not, well, we know that two lines are parallel, so in other words, these two lines are going to be parallel. What we want to show here is that 2 and 7, angle 2 and 7 are supplementary. You may look at this and see that there's not really a direct relationship between 2 and 7. They're exterior angles, but that's about it. What we can do here is show that 2 and 3 are the same, and we can also show that 5 and 7 are the same. Why? Because they're both a pair of vertical angles. Then we know something about 3 and 5. 3 and 5 are consecutive interior. And from there we know that they're supplementary, and we can get this link here. And so that's what I'm going to do. There are other ways to do this proof. That's the route I'm going to use to explain this. And so let's take a look at it. If I look at my basic chart of statements and reasons, first thing I'm going to do, of course, is write my given and say that T is parallel to H. Of course, that's just given. I also know here that, looking back, I want to say that 2 and 3 are vertical angles, and 7 and 5. I want to say that they're vertical angles first before I state that they're congruent. So in order to do that, I'm going to get here that angle 2 and angle 3 are, and I'm going to write vertical angles. Similarly, I'm going to write that angle 7 and angle 5 are also vertical angles. And the reason for it, whenever I just point it out from the diagram, is going to be the definition of vertical angles. And I'll just repeat that there. We also know here then, because they're vertical angles, we know that the measure of angle 2 is going to be equal to the measurement of angle 3. And similarly, the measurement of angle 7 will be equal to the measurement of angle 5. And the reason is actually something called the vertical angle. So the vertical angle theorem. You could also say that, well, by the way, all vertical angles are congruent or all equal. That's fine. What I'm going to do here is to say that, well, we know they are, but we've kind of shown these ones. I want to start talking about these ones here. And so 3 and 5 are also consecutive interior angles. I need to point that out first. So I'm going to say here that angle 3 and angle 5 are consecutive interior angles. They're consecutive interior angles. The reason is because that's the definition of consecutive interior angles. Okay, so we know that they're consecutive interior angles. As a result of the being consecutive interior angles and these being parallel, these are going to be supplementary. So I'm just going to say here that angle 3 and angle 5 are supplementary. How do I know that they're supplementary? Well, that's because of the consecutive interior angle theorem. Okay, because of the consecutive interior angle theorem. Now that they're supplementary, I can show here that the measurement of each, when you add them up, measurement of angle 3 plus 5, well, that's going to equal 180 degrees. Why? Because, well, if they're supplementary, that's the definition of supplementary. Now it's pretty straightforward. I can substitute angle 2 for angle 3, and I can substitute angle 7 for angle 5, which is ultimately what they want me to prove, is that they're supplementary. And so I'm going to get here that the measurement of angle 2 plus the measurement of angle 7 is all equal to 180. I basically substituted, there's a substitution property of equality. And last but not least, now that they add up to 180, I can say that angle 2 and angle 7 are supplementary. And that basically takes care of my proof. Angle 2 and angle 7 are supplementary. Why? Well, if they add up to 180, that's the definition of supplementary, and we're done. And we've kind of proven that. There are other ways to do this proof. That's the route I'm going to choose today.